Hi everyone, I'm Wenzhe from Stony Brook University. Today I'd like to talk about HotStrokes, a word gesture shortcut on a trackpad. Command input is a very common activity in our computers. Typically, there are two different methods to input a command, the hotkeys and the menus. Menus are easy to use, but it's inefficient. For example, when I use Photoshop, it's a very powerful but complicated. However, the well-designed menu can get me to the command that I need. But when I frequently use the menu, I need to move the cursor back and forth between the menus and the canvas, so it will cost me a lot of time. And the hotkeys can help the user to improve the input efficiency. However, it was hard to memorize them. Here is the hotkey list. Is a hotkey list for Photoshop. I spent a lot of time to memorize those hotkeys. Basically, I can only remember 7 of them. It is very hard to remember. So, as we can see, menus are easy to use, but it's inefficient. Hotkeys is efficient and it's fast, but it's hard to learn and memorize them. So, can we have a command input method that is both efficiency and easy to learn? Our answer is HotStrokes. HotStrokes is designed especially for the laptops with a trackpad. Imagine there is a virtual invisible keyboard on top of the trackpad. And to enter a command, the user needs to click down the modifier key and draw a gesture just like the word gesture, just like the name of the command. For example, to enter stop, I just need to press down the control button and draw gestures through STOP on the trackpad, just like on a soft keyboard on our phones. And the keyboard above the trackpad can also help the users to help the user to remember or recall the keys of the keyboard. This is how it works. We only need to press down the trigger button and make a gesture. Users can use HotStrokes everywhere on a laptop. Now here, I'd like to show you a demo. For example, if I want to open a tab on Chrome, I just need to press Control and draw tab, T-A-B. And I will open tab. If I want to open a window and build a new window on Chrome, I just need to press Control and draw new, N-E-W. And we've got a new window. And we can also use it in other software such as Excel. And we can try to open a new file. We draw open. And then you can select the thing that you want. Okay, now let's go back to the talk. Next, I will first explain how it works and then show the evaluation of HotStrokes. We started by applying the algorithm that was introduced by Jingjie and Paula Christensen in 2004 and to decoding the gesture typing. First, we stretched the standard QWERTY layout to fit the trackpad and applied the structural algorithm to recognize the gesture input. The purpose is to test how the basic sighting works. We run a study with 12 users to input 80 commonly used commands. These are the 8 commands from menus of Apple OS X. We chose these commands to cover all the 26 English letters from A to Z. Here's the accuracy. As you can see in the figure, the x-axis is the size of the dictionaries. It starts from 10 and ends at 80. The accuracy of the gesture input drops as the number of the command increases, it finally reached 74% on 80 words dictionary. The result shows that if we simply use a QWERTY layout and apply the SHRK2 algorithm, it does not work well. So why does this happen? The first reason is that we don't have the language model and only use the spatial scores for each word, because we ask users to enter the command one by one. And another reason is that it is hard for user to follow the template accurately. In our study, we expect the user to enter a gesture like this. The ideal gesture should go through the command letters on the imaginary virtual keyboard. For example, when you draw a cut, the trees should start at C and go through U and end at T. However, according to our study, even with the help of the keyboard above the trackpad, it was highly possible that the user may draw a gesture like the pink line. So, according to the behavior of the users, that it is possible that the imaginary key positions are different than that ones on the standard QWERTY layout. To understand where the user thinks the key is on the trackpad, we perform the following analysis. We analyze all the gestures and get a new imaginary keyboard layout using dynamic time warping. In the example, we use DTW to match the 3 points in the template to the gestures. And using this method, we can get the letter positions in the gesture. Here's how it looks. This is the new virtual keyboard that we get. It shows that the key positions clustered near the central region of the trackpad. It also suggested that the width of the new virtual keyboard is smaller than the width of the standard QWERTY layout. The most important thing that the imaginary key do not evenly distributed on the trackpad. So this is the spatial model that we used in the HotStrokes. Now we propose the first method, spatial model adaptation. We can use this method to improve the accuracy and decode the gestures again. Here's the result. As we can see in the result, the spatial model adaptation in general improve the accuracy of our inputs. And you can see in the figure, especially in the dictionary size that is larger than 30, it improved a lot. And it increased the accuracy from 74% to 78% at the dictionary size of 80 words. Now we have the spatial model adaptation, but as you can see in the previous slide, we can still improve the accuracy. Look at these figures. We found that it was hard to recognize gestures with a similar shape and the positions. There are some words such as copy and cut. The gesture templates of these two words are very similar, which means if you input a gesture cut, the scores on cut and copy can be very close to each other. So it is possible that when you draw cut on the trackpad, the first candidate of your input is copy, not cut. So you will get a wrong result. To solve this problem, we should give user more suggestions. Here's how it looks. The user can use this menu to use this layout to select the word that we want. And the challenge is to decide when to give them suggestions and how many suggestions should we give them. On one hand, if we didn't give any suggestions to the users, it is possible that they may get the wrong answer. They may get the wrong result. And just like we talked before. And on the other hand, if we always give the user suggestions, it may introduce unnecessary gesture cost. Because the first suggestion maybe exactly the one that you want. To keep balance, we introduced a strategy called dynamic suggestion. We calculate the suggestion scores of the top 1 and top 2 candidates. If they were close enough, we will show the suggestions. Then we set a sigma as the threshold. We want to optimize the value of the sigma so that the suggestion won't show up too often, but the user will still get the suggestions when they want it. We use F2 to measure how good sigma is. This is the definition of F2. It controls the weights of recalls and precision. Both are very common measures for gesture suggestions. And F2 weights the recall higher than precision, and we use a linear search to find the optimal sigma with the highest F2 score. As we can see in the figure, we increase the sigma from 0 to 1 and find the sigma with highest F2. The optimal sigma is 0.0468. We use the same method to show in 3 suggestions. So, with the help of dynamic suggestion, we further improve the accuracy of input. Dynamic suggestions brought input accuracy above 90%, especially for the command that is within 40 commands. On 80-word dictionary, it increased the accuracy from 78 to 87. Now we have 2 methods to spot HotStrokes: spatial modal adaptation and dynamic suggestions. We invent the HotStrokes to complement the existing menu and hotkey methods, but not to replace them. So we conduct a user study to evaluate how HotStrokes will improve the performance of the existing command input. We recruit 24 users in this experiment and conduct a between object study. Half of the users were in condition 1. They were only allowed to use the hotkeys and the menus. And half of them were in condition 2. These users were allowed to use the HotStrokes, hotkeys, and linear menus. Let's see that this is the UI of the linear menu. The users can see the hotkeys for each command in the linear menu. We set 6 categories of commands: animals, vegetables, food, office, clothing. These are the common things that we can see in our daily life. And each category has 12 commands. If the user triggered command by hotkey, they can also see the hotkey combinations. And this helps to enhance their memory. If the command was triggered by HotStroke, we still also show the hotkeys for the command. Here's the result. The average input time using only linear menus and hotkeys is 3.3 seconds. With the help of HotStrokes, the average of input time is 2.252 seconds, which is 24% faster. Now let's look at the adoption rate. The adoption rate shows the percentage of the command were triggered by a specific method. In this figure, when HotStrokes was enabled, 64% with commands was triggered by HotStrokes. It's very easy to adopt. And the user also substituted 91% of the linear menu uses with the help of the HotStrokes. So, in the evaluation, the HotStrokes lead to 24% faster command activation overall, and it is easy to learn, replace 91% of linear menu usage. To sum up, the HotStroke is efficient and easy to learn, and it greatly complements the existing command input method. And we use the spatial mode adaptation and dynamic suggestions, and they are effective to improve the HotStroke's decoding. At the end of my talk, I'd like to show you a new demo. We have open sourced the HotStroke and the installation files, and it is available for download now. Now I'd like to add a new slide. And a text box. Thank you. Let me change the size. Give me a second. Size of this, 28. Make it bold. Okay, that's all. Thank you.
Time for some questions for the microphone.
Hi.
Yeah.
Sylvain Malacria from INRIA. I have a question. I might have missed something, but I don't really understood how you teach novice users which gestures they have to perform if the layout of the keyboard is not printed on the touchpad.
It's not printed on the touchpad because there's a keyboard above the touchpad, so they can see the locations of the keys above the touchpad. This is exactly the layout that we use on the touchpad.
Yeah, but when you did a demo for opening and closing, opening a new tab and closing a window, I think your gesture was tab. The word you
yes,
typed.
tab, T-A-B.
Yeah, so I think in my browser I have like new tab, close tab, previous tab, next tab, and how do I know which word I have to type for a given command?
For now, we only use the keyword of the tab. Actually, in the application, we allow the users to define the command that they want. If you want to, you can set up your new command. For example, if you prefer next tab, you can just draw next tab and record them. There's a layout, there's an interface to enter the command. You don't have to enter tab. This is my definition. You can use your own.
Okay, so it's user defined.
Yes, you can.
Okay.
Hi, it's very nice talk. And
Hi.
I have a question. When you choose to use the normal keyboard, have you considered two alternatives? One is to use the 9-key keyboard. The other is directly draw the handwriting like cut on the trackpad.
You mean use the nine keys on the trackpad?
Yeah.
We have considered that situation, but the gestures of the QWERTY layout are easy to learn for the users. If you use a 9-key, it may be possible that it will increase the inputting speed because the area is small and you can draw it fast. But our purpose is to make an efficient way. So the user will open this software and immediately use that. So if you use a QWERTY layout, we have a physical keyboard about that. You can learn that easily.
Sorry. The other one is to.
Could you put that offline? Okay. We're going to get time for one more, Xiaojun.
A really quick question. I wonder if you, in your understanding, how this compares to command strokes.
The command strokes, we didn't include the experiment in that part. I think we might include that part in the future work.
But just conceptually, even, how do you think they are? What are the pros and cons of command strokes versus what do you call hot strokes? Conceptually, in
my view, I think that our method should be faster.
Because
you see that you have a lot of hotkeys in the software. For example, in the Photoshop, and if you use command strokes, it may be not good enough to define so many hotkeys using simply the.
First of all, explain to the audience what command stroke is, or if you understand what I mean. Do you understand what I mean?
The command stroke is that ones that using the letters of it to input the letters to trigger the command. You draw the letters.
Oh. Okay.
So could you repeat?
Yeah. Well, let's say. Let me just make it explicit. So you start with the control key and you make a gesture, and that's I think Christensen Zheng 2015 or 16. 2004. The year after the paper you cited, that was all about applying the same idea to commands. And the command, using the word space to command. You can even use the initials or shortcuts of of same words to do copy paste and everything
Yes.
you presented. But the difference in there is that instead of using a two-hand modifier to switch mode, you use a signifier to start, say, from a command key, and then the rest of gesture is just expressing either the words or a shorthand of the words for the command. It's very much what you describing here. The difference is that it's a unified command itself versus a modifier two-handed action, then you draw the stroke. So I don't know what the pros and cons are.
Answer very quickly, please.
Okay.
Just a very quick one, and then take it offline, please.
Okay, great. Thank
Okay, thank you.